We have already been through this in the Google Meet, but if you missed this, then we're going to go through the addition and subtraction of roots, and obviously if you did want to go back through anything, this is going to give you an opportunity to recap and review anything that you didn't understand earlier on. So let's jump straight in with a little recap. So in the last lesson or video, depending on how you structured it, we looked at these three things: simplifying, multiplying, and dividing. When you're simplifying, that's like the first one, we got root 72. We said the first thing you need to do is find a square number, a perfect square, that goes into the number you're trying to simplify. So 72, I would break it down into root 36 and root 2, because 36 times 2 is 72. Root 36 is 6, so I would have 6 root 2. If that doesn't make sense to you, still not sure about that, then I would say go back to the previous video, because that's the fundamental skill. And if you can't do that one, then what we're going to do later on in this video is kind of redundant. So you need to make sure that that first step, you understand roughly what it is that you're doing before you go any further. Similarly, when you're multiplying, so the next one we've got root 3 times root 4. We make one big root with both of them in, 3 times 4. 3 times 4 is 12. The other thing we could have said is that the square root of 4 is 2, so it's the equivalent of 2 times root 3. And you have to simplify your answer here, just like we've simplified our answer here. Finally, for the last one, root 90 divided by root 30, we do 90 divided by 30 as one big root. 90 divided by 30 is root 3, and because 3 is a prime number, it can't be simplified. So that's what the previous video looked at. If any of that doesn't make sense still, that's the kind of fundamental skills, so I would say go back and have a look at that first. Okay. Let's jump in then to what we're going to do today. We're going to start off with a couple of very straightforward examples. We've got root 7 plus 5 root 7s and 4 root 3s minus 12 root 3s. The key here is to think about algebra and surds and the rules being roughly the same for both. If I had a question which said x plus x, you can say, oh, well, both of them are x's, they're the same thing, I've got 2 of them. X plus x is 2x, not x squared 2x. But if we tried to add together x and y, well, they're two different letters, so we can't add them together. We can't do anything with that unless we know the value of one of them. Roots follow roughly the same rules. Here, we've got a root 7 and a root 7. I've got 1 at the beginning and 5 at the end. So if I have anything, I've got 1 plus 5. Well, 1 and 5 make 6. So if I've got 1 root 7 plus 5 root 7s, I've got 6 root 7s. How many do you have altogether? Well, they're both the same thing. 7 can't be simplified. You've got 6 of them, and that's it. Similarly, when we're subtracting, we can do the same thing. You'll notice here we've got 4 minus 12. Now, 4 minus 12 gives you a negative value, but that's okay. You'd say that you've got negative 8, because that's 4 minus 12, but you retain the square root. And that would be your answer. Negative 8 root 3. It's negative first, then it's everything else. And remember, we say negative 8 root 3. It's not negative 8 root 3. Well, it is technically, but we think of it as a negative 8 root 3. So when they're both the same, really straightforward, you just add or subtract your values. The only difficulties come when we've got different roots, and I'm going to show you how to deal with that now. So let's look at this one here. We've got 24 plus root 6. So at the moment, the common mistake I see students making is they try and add this together to get 30, but you can't do that. That's not allowed. Incorrect. Okay? We can only just put them together when we are multiplying and dividing. When we're adding and subtracting, we have to do something different. Now, what we could say about 24 is that 24 can be split up, like we were doing in the simplifying, into 2 separate factors. 24 can be written as 4 times 6. 4 times 6 is 24. So now we have a situation where we have a root 6 and a root 6. We've got the same roots. Once you've got this situation, then we can simply, actually I want to keep that green. We can say, well, that gives you 4 plus another 1. You've got 5 root 6s. And you can see we've got that common thread of the root 6s. No, thank you. So we've got something like that. So when we're adding them, and we've got 2 standard roots like that, first thing we need to do is put them in the same base. As you can see here, I've highlighted it in green. Root 6, the root 6s can be combined together. But don't just add 24 and 6 to get 30. Let's look at another example. Now we've got a few different parts. We've got a negative, we've got a 2 root 5, and we've got 45. So we've got 3 different numbers. So we look at these 3 and say, okay, well 20, 5, and 45. We've got 3 parts. All of those numbers are on the 5 times table. So what we need to do now is to split this up into its factors. We know that 5 is a factor of all of them. So we know we're going to be dealing in root 5s. We then think, okay, 5 times what is 20? Well, it's 4. 4 5s are 20, but it's also negative because we have the negative here. We've already got the next one. We're given the 2. That doesn't need to change. Finally, we've got 45 is 9 times 5. Now we've got these, we can look at, are there any ways we can simplify? Well, yes, we can look at the 4. 4 becomes 2. Root 9 is 3 times 3. We've still got all of our root 5s. You can see I'm color coding them. And we're still adding them together. That one's negative, and that one's still a 2. And now we have a situation where we have a negative 2, a positive 2, and a positive 3. Minus 2 plus 2 plus 3 is going to give us exactly 3 when we add all of those together. And then we just pop the root 5 on the end. Okay, let's look at another one. Now we've got an 8, a 27, and a 3. Now the problem we're going to face here is that 8, 27, and 3 do not have any common factors. But 27 and 3 do. So we'll just deal with the first one on its own, first of all. We realize that 8, 27, and 3 have no common factors. So we're just going to deal with the 8. Root 8 can be written as root 4 times root 2. And we've still got this 3 outside. We're going to ignore the 3. We're just going to deal with the root first. We look at this and we can see that root 4 is 2. Hopefully you'll see some of the same numbers coming up, like root 4, root 9, root 16. They come up quite a lot. So we bring the 3 down. We've still got this root 2, but now we've changed the root 4 to a 2. Finally, just remember that everything we're doing here is multiplying. So it's like we've got, when we have 2 terms, like 3x, it's like 3, think about 3x is like 3 times x. Yeah. Same here, this is like 3 times 2 times root 2. So take the first part now. Now we're going to deal with that 3. 3 times 2 is 6. And we just keep the root 2 as it is. So we've dealt with the 3 to the root 8. We're going to come back to that again later, but for now, that's the first part done. Now we're going to look at the next one, which is the 227 and the 3 root 3. We look at 27 and we say, okay, let's split 27 up. 27 can be 9 times 3. We'll leave the 2, like I said, always. We'll leave that number at the front, the coefficient, to the end. And here we've just got 3, and again we've got the root 3. So we can't do anything with that, it's already been done for us. We look at the 9 and we can see that the 9 here, 9 can become 3 because 3 times 3 is 9. We've got the 2 here, we've still got that root 3. And then we've got the root 3 here, and 3 of them here. Again, we end up with that 2 and a 3. We can times them together, and that will give us 6 root 3s. And then we've got 3 root 3s here. Didn't like the lack of color coding. Now the root 2 and the root 3 can't be combined, but the root 3s and the root 3s can be. So we can simplify that by looking at this section here. And we can see that 6 and 3, all together we've got 9 root 3s. But we've still got the 6 root 2s. And we're adding them together. And that is our final answer. It's okay to have 2 different roots, or roots and numbers, in your final answer. The only thing to remember is that when we've got root 2s and root 3s, they can't be simplified and they can't be combined. So you have to leave both parts in your answer. So your answer would look something like that. Again, the key idea we're looking for every time is, can I make anything the same root? And here we could do it for some of it, just not for all of it. So you do it for as much as you can. The final thing I'm going to show you is and this is like a technique which we're going to use in, not maybe today as much, but in some of the later lessons, is where you can work the other way around. When we've been simplifying, we've been trying to end up with something that looks like this. But sometimes we can work backwards and we can get back to what it would have been if it was just a root without a number in front. So let's think about this 3. We know that 3, hopefully by now we've seen, is the square root of 9, because 3 times 3 is equal to 9. So when you have something like this, you can take that number in front and you can say, okay, well 3 squared is 9. So that 3 can be rewritten as the square root of 3. Sorry, square root of 9. Keeping everything else the same. When we have 2 roots together like that, we can multiply them together. 9 times 2, well, 9 times 2 is 18. So keep that the same. And then we can say, 9 times 2 is 18, so that's the same as 18. And we can put those together to get 2 root 18s. Now at this stage, you could simplify, but this is a technique we might use to solve certain types of questions where we don't want to fully simplify. And I just wanted to show you that we can do that process both ways. You can take an 18 and change it into 3 root 2, or you can go backwards and express it as a whole number root. So it's a 2-way process. Finally, let's look at this one again. Or similar question, sorry, with root 18. This time we've got root 9. Root 18, thinking back to last lesson, we can simplify by making it root 2, root 9, plus root 9. Root 9 is 3. Here we've got 3. You may sometimes see something written like that. We shouldn't write it like that. We should always put the whole number first. Now, here we've got a situation where you've got 3 root 2 plus 3. You've got a square root, or a surd, and a whole number. And at this stage, because again, you've got root 2 and a 3, they're not the same thing, you can't add them together, then it's perfectly okay to leave your answer as a root or a multiple of a root and a whole number. And that's also okay. Sometimes you'll simplify it to the point when you end up with whole numbers, and that's fine. So you can see answers that look like this. So that's adding and subtracting surds in a nutshell. Just remember the key rules. Okay, just like x and x makes 2x, root 7 plus root 7 would be 2 root 7s. We can add them together because they're in the same base. It does not equal root 14 or 16. Okay, so don't do that. When you've got more than one of them, that's also okay. That gives you 2 plus 5 is 7. You can also do the same thing in reverse. You can subtract, and you just think, how many do you have? This always works when they're the same. When you've got roots of different values, then you have to simplify first by making the same base. And then you say, well, I've got 3 minus 1 is 2. So the key thing here when you want to add and subtract is they need to be in the same base. And if any other more specific skills you wanted to recap, then obviously you can go back on this video and look them up. Enjoy and have a go at adding and subtracting some roots.